Today, we're going to get into a really cool piece of engineering that solves a surprisingly common problem. How do you move all kinds of different liquids? It's all about picking the perfect tool for a very specific and sometimes a very, very messy job. So just think about this for a second. How can one type of machine handle something as clean as drinking water, but also something as thick as sludge and something abrasive like sandy grit? It seems kind of impossible, right? You'd think one of those would just destroy the machine. So what's the secret sauce here? Well, the answer comes down to one single critical part that you can swap out. You could absolutely call it the very heart of the pump. And that part is the impeller. At its core, it's a spinning disc with blades, and it's attached right to the pump's main shaft. This is the component that does all the heavy lifting. It grabs the fluid and gives it a massive boost of energy. So how does it actually do that? It's a really simple but powerful idea. The impeller spins, and it spins fast. Its blades, which are called vanes, catch the liquid as it comes in, and then good old centrifugal force just flings that liquid outwards. This whole action turns the spinning motion into fluid pressure and speed. I mean, that is literally how a pump pumps. Okay, but here is where it gets really interesting. Not all impellers are built the same. The reason they're so versatile comes down to one big design choice. Are they open, semi-open, or closed? And that whole choice? It's all about a simple feature called a shroud. You can just think of it as a cover plate, kind of like a disc that sits on the side of the blades. And believe it or not, whether you have these shrouds or don't, is a total game changer. It changes everything. You can literally just count the shrouds to know what you're dealing with. A closed impeller has two of them, one on each side, so the blades are completely sandwiched in. A semi-open one has just one shroud, which acts kind of like a back plate. And the open impeller, zero shrouds, none. It's just the bare blades out in the open. This one difference dictates everything that pump can do. All right, so let's connect the dots. Let's see how this one design choice actually plays out in the real world by matching each of these impeller types to the specific stuff it's built to handle. First up, we've got the closed impeller. You can think of this one as the high-performance precision tool of the group. It's all about efficiency. And that efficiency comes from its design. Those blades are totally enclosed on both sides by shrouds. This makes it perfect for thin, non-viscous liquids that don't have any solids in them. We're talking things like clean water, hot oils, even certain chemicals. That closed design is amazing at building pressure, and it stops the fluid from slipping backward, which is what makes it so efficient. But what happens when the liquid isn't so clean and easy? What if it's thick, sticky, and just plain hard to move? Well, for that, you need a different tool for the job, the semi-open impeller. See, by getting rid of one of those shrouds, the design opens everything up, giving the fluid way more room to move. It's specifically built to handle those thick, viscous liquids that would clog up a closed impeller in a heartbeat. This is exactly why it's the key part in what people call non-clog pumps. When you've got to move stuff like sewage or thick paper pulp or even sticky molasses, this is the one you want. And finally, for the absolute toughest, grittiest jobs out there, we've got the most rugged design of them all, the open impeller. And this is where we really need to see the difference. While the semi-open impeller is great for thick liquids, the open impeller is for liquids that have actual solids in them. The problem here isn't just stickiness anymore. Now you're dealing with sand, pebbles, and other debris. So the logic is simple. Get rid of all the shrouds, and you get the absolute maximum clearance for all that stuff to pass right through. So yeah, with no shrouds at all, the open impeller is the undisputed champion of handling solids. Its whole reason for being is to not get clogged by debris. This is the impeller you have to have when you're pumping water mixed with sand or little pebbles or clay. It's all about that maximum clearance. So how much solid stuff are we really talking about here? A lot. Seriously. These open impellers can handle liquids where solids make up as much as 25% of the total volume. That's a full quarter. That's an incredible amount of grit and junk to be moving through a machine without it just grinding to a halt. Okay, so we've met all three types. Let's wrap this up and do a final breakdown, just to make sure everything clicks into place. So let's lock this in. If you've got thin, clean liquids, like a city's water supply, you want the closed impeller. Its two shrouds give you that high efficiency. If you're dealing with thick, viscous stuff like paper pulp, you need the semi-open impeller. That one shroud is the key to preventing clogs. And finally, for liquids full of solids, like draining a sandy construction site, you go with the open impeller. No shrouds means maximum clearance. It really is that simple, matching the right tool to the right job. The impeller is just a perfect example of how a tiny design tweak, just adding or taking away a simple cover plate, can solve a massive range of really complicated problems. It kind of makes you wonder, right? What other brilliantly simple designs are out there, hiding in plain sight, just making our world work every single day? It's definitely something to think about.